Okay, so in this video we're going to continue on with our linked list class. Before I do the insert and the peek method, we're going to go through and fix some of the typos I put in together. So I accidentally called my constructor link list instead of linked list, which is what I named the class. And then I do have a null instead of null pointer. I'm still in old school C++ where null pointer didn't exist sometimes, but so now we're going to go on and we're going to create the insert method and the peek method. So this is still templated. So I'm going to grab my little template there and I'm going to put in my code for my insert. Now if you look at the comments for this section for insert, we are going to add to the back of the linked list. All right, so that's what we're going to be implementing for this particular situation. So this is not returning a value, it is linked with an ed list this time. Not going to put it in wrong. And I'm inserting data of type, that way it could be any type. Okay, in order to get this working, we need to create a new node. And then there's two situations in which this will happen. If the list is entirely empty, we're going to define what our front node is as whatever the element is coming in, the new element. If our list is not completely empty, then we're going to assign it, we're going to change where the back of the list is. So either way, I need a pointer to my new node. So there is star, I'm going to call this temp, and it is equal to a new node. I want to assign the data, so section, to whatever data my parameter has coming in. So I'm assigning this to the data section of my new node. Now I have to put in an if statement here for the two situations I was talking about. If there is no front node, then I'm going to say my front node is equal to the new node temp. And I also want to set my back node equal to temp, because if there's only one item in the list, then the front and the back are both pointing to the same node. Okay, any other time, I don't have to change the front. All I have to do is change the back. So I'm going to say temp next equals null pointer. That way this is marking as the end of the list. I'm going to change where my back is pointing to. So back arrow next is equal to, it's not null anymore. The back of the list is now pointing to my temp node. I've now pushed that in. Now I'm going to set the back equal to my temp node, because now the back is now at the new end of the list, which is the node I've just inserted. And so that should insert our element into our list. Now if we want to see that it is working, we can add a peek method. And our peek method is just going to allow us to peek and look at any particular node in our list. Okay, I still have my template I'm going to put in for my peek method. And this time, instead of returning void, it is going to return the data at whatever position that is. So I'm going to say type. There's my linked list of type, and it's named peek. Okay, so this index value will tell us at what position we're going to be looking at. So where are we viewing the fifth? Are we viewing the second? What have you. So I need a counter to keep track of where I am in the list. So I'm just going to say current node number, that equals 0. I also need a pointer for the current node. Set that equal to front. Now you'll notice there's two ways I'm doing this. I want to also show you demonstrate this auto. Auto means auto define this as whatever this is. You can only use this auto keyword when declaring a pointer and assigning it a value at the same time. So I couldn't use this auto in defining my temp because I'm creating a new node there. So now I have my current node and a pointer, a counter that starts at 0. I want to keep going through my list until I come up with this NDX value. And I also need to throw an exception if they give me a value that's not in the list. For example, if my NDX value is greater or equal to the count of nodes in the list. If that is, I need to throw some sort of exception. There's my runtime error that says the item does not exist. Okay, so that will handle if they give me, if there's only 5 elements in the list and they're trying to peek at element 16 or something like that. That will throw this runtime error for us so it doesn't crash our program. Say, now I want to keep counting. Well, my current node number is less than the NDX value that the user type is sending me, what they're searching for. So if that's the case, then I'm going to increment my current node number, and I'm going to also increment where my current node is at. So my current node is currently at the front, but I'm going to set it equal to its own next value. Current. Did I seriously put 3 R's in current? All right. Stop me next time. So current node equals current node next. I feel like there's an error somewhere. Dare I compile this? Open, close. Oh, I'm missing a semicolon. But other than that, all right, that's just because we haven't implemented that part yet. Okay, so currently, all errors barring, there might be, if there are any errors, I'll fix them in the next video or future videos. But this should now work. This should take us and we'll get this particular index value. We'll search through the list till we come up with that value. And now we need to return where the data that current node is pointing to. So here I'm going to say return current node data. That way it will return back the data that's in this current node, which happens to be at whatever NDX position. Okay, so that is it for our current node class. I did forget we did have this count variable that's keeping track of how many we are. So in our insert mode, after we've added our node in, we need some sort of count plus plus to keep track of where we are in how many nodes we have in our list. Otherwise, this logic here, comparing it to count, wouldn't work. All right, so that is the insert and the peek method. We will catch you in the next video as we code the, let's see what's next, remove and our extraction operator.